All right, everybody, we'll kick things off. Thank you very much for joining us today on another month of our Yotta webinar series in the Yotta Know. Today's topic is bringing it all back down to basics. It's an exploration of our core technology and probably what most of you are curious about when you hear about Yotta. The topic today is exploring the SolarLEAF, commercial rooftop distributed battery storage. I am your host, the VP of Sales, Mr. Ryan Davies. I'm based out of Raleigh, North Carolina. And as always, I'm joined by my colleague and great friend, Mr. Christopher Barrett, who is our Senior Director of Applications Engineering at our headquarters in Austin. How you doing, Chris?
Doing fantastic today. Hello, everybody out there.
So before we get to the prize announcement, we will have a Q&A section at the end of the event. So if you want to put your questions into the live chat, we'll try to address as many of them as we possibly can at the end of the webinar. Like I said, we'll do our best, but what I can promise you, if we don't get to your question, you will definitely be followed up. We'll have somebody on the sales team reach out and follow up to your inquiry. But yeah, as soon as the webinar is over, we will be having a random drawing. We will pick a name and somebody from the marketing team will contact that individual, and that person will be the recipient of a fantastic Yotta swag giveaway package. So stay tuned for that. The agenda today is as follows. We have the Yotta ecosystem, followed by the SolarLEAF. Why the SolarLEAF? How do we do it? How do we do it? It being the SolarLEAF. A case study. Yotta Energy's commercial three-phase microinverter, affectionately known as our DPI. We'll go over very briefly some spec sheets. Something that's pretty interesting, I think this is maybe the unsung hero of the webinar and the product, is the online monitoring portal, an installation, a quick review, and then we'll go and give a nod to some of our partners before we get to the Q&A. The partners section is really just there to let Chris get a drink of water before we start peppering with questions after he's done with his presentation. About Yotta Energy. Our motto is energy made simple. Yotta is leading the transition to clean, renewable energy by making energy simple. We have a complete range of distributed solar energy technologies for the commercial and industrial market. Yotta's technologies were made with the goal to convert commercial buildings into solar power plants. And we're pretty unique in that. We're the only company that I know of that focuses on small to medium C&I. No resi, no large commercial or utility size situations. We are only small to medium C&I. We were founded in March 2017, and as I mentioned, our headquarters is located in Austin, Texas. We're about you'll find about 40 people. We have a number of awards and different recognitions that you can find available and listed on our website.
Well, fantastic. Well, thank you so much, Ryan, and thank you everybody for joining. I'm going to take over from here. One of the first slides I'm going to present today is this particular slide. It's one of my favorites. Actually, I love talking about this because one question that I get a lot, and we get a lot here at Yotta Energy, is it Yotta or is it Yoda? And clearly, it is Yotta, not Yoda. So to continue that play on that word here, what does Yotta mean? And that's another question we always get is, what does Yotta Energy mean? And Yotta actually is a prefix for the 10 to the 24th power in the metric system. We're all very familiar with the metric system and all the things we talk about a lot in kilograms, mega, giga, tera. This is just basically Yotta, Y, 10 to the 24th or 1 septillionth. Just a little education for everybody out there. So it is Yotta, not Yoda. Let's talk about the ecosystem a little bit now. Let's just get into the meat and potatoes of what we're doing here. The Yotta ecosystem, as Ryan said, this is for the small commercial C&I buildings. What we're looking at here is the SolarLEAF itself. This is actually the core technology, the battery that lives and breathes on the roof underneath the modules. The solar inverter here. This is a 4-port inverter, which we'll talk a little bit about towards the end of the presentation, how the ecosystem works together. Obviously, the solar modules are working in parallel with the inverter and the battery. We also, as Ryan was mentioning, is the online portal here as well. This right here is the magic. This is to be able to monitor the system. panel by panel throughout a commercial environment, and be notified of any kind of issues on that site relatively quickly to be able to solve any kind of issues in the future. And also have some type of a kiosk view, and maybe perhaps in a lobby area, something like that. You can actually see power production throughout the day through the lifetime of the system. In addition to the power production on the roof, we also carry and have a car charging system, a level 2 charger that can be mounted outside of the building. So in conjunction with everything that's happening on the roof, we can also charge those cars that are sitting in the parking lots. Moving on. Energy storage ready. This is one thing that we always talk about here, and we always talk about when we install a Yotta system. Yotta systems are, like I mentioned, they include the modules, they include the inverter, and they also include the batteries. The nice thing about this particular system is this: you can actually install a system today with racking, inverters, and modules, and we call that energy storage ready. So that means that you can actually add a battery at your convenience in the future. This right here just gives you an example of that system, the solar plus the storage included. We have the module that then goes directly into the SolarLEAF battery. From that goes out to a 1 port on this 4-port micro inverter. One question we always get, let's say, is it a requirement to have a SolarLEAF under every single module? The answer is absolutely not. You can have a system just like this. The configuration is very flexible. This gives you the ability to have a solar module plugged into the input of the SolarLEAF. The output of the SolarLEAF then goes into this inverter, as we call a DPI, or the dual power inverter. You can also have, as we show here, a solar module that comes directly out into the input of the inverter. This gives you the dual power input. This gives you the ability to plug in either directly from the module or directly from the battery. The inverter itself will understand what it's talking to and be able to convert that power from DC to AC. Let's talk about the SolarLEAF a little bit. As Ryan was mentioning, this is kind of a revolutionary approach to storage, basically, for any kind of commercial environment. We're typically used to seeing larger systems, typically located inside a building or outside the building. This right here is the world's first truly integrated solar and storage, because it lives on the roof, because it talks under the battery, directly to the battery to the inverter. What we're trying to do also is simplify the installation and minimize the maintenance. You're looking at a 1 kilowatt-hour battery that sits on the roof, acts as 2 ballast plugs. Really, again, simplifying. It's a plug and play from the module to the SolarLEAF to the inverter. Couldn't get much easier. Maximum flexibility and high efficiency. Because we're on the roof, this is a DC to DC system. DC from the module to the battery, then to the inverter. We're minimizing the amount of losses that you're going to have on the roof. Instead of having batteries sitting downstairs at an AC coupled system, this is a DC coupled system. Architecture that grows with energy demand. As I mentioned, you can install a system today with racking, modules, and an inverter, and add batteries in the future. You can add batteries to 50% of your load. You can add batteries to 100%. The only limitation you have today is the number of modules. I need 1 module to charge 1 SolarLEAF. That is the limitation. Highest in safety and application. Well, like much I mentioned, this is a 1 kilowatt-hour battery. The chemistry is LIFO. So right there, very, very safe technology and very safe technology and chemistry. And we believe, and we'll talk about this a little more, lowest system cost. Again, this is right here. There's a lot of cost when it comes to adding batteries to systems. Because it's on the DC side, we're saving a lot of cabling, a lot of information is being taken care of right there on the roof. So one of the 3 things that we actually specialize in here is the battery system types and what we're actually going to do. Number 1, energy arbitrage. Being able to discharge this battery as needed from the utility side. That's number 1. Peak shaving. we're actually able to look at demand charges coming in. We're actually able to monitor consumption of the building, production on the roof, and actually be able to discharge the batteries at any time to be able to manage any kind of demand that is happening at any given time. And last, of course, time of use. This is actually very popular in California, and I think it's coming across the country. Time of use is a situation where power prices, price per kilowatt hour will go up. California, for example, from 4 p.m. to 7 p.m., the price almost doubles for the kilowatt hours. The nice thing is you can charge your batteries in the morning and actually discharge those batteries during that time of use, again, to save you money. This right here is just a quick video. It just explains or shows exactly how the system goes in. What we're demonstrating here is actually a panel cloth racking, as you see on the front. You can see the inverter being placed into that tray. You can also see the SolarLEAF being placed in between where the ballast blocks would normally sit. Again, the unit itself is 53 pounds, so it actually is equivalent of 2 ballast blocks. Again, I mentioned the plug and play piece of this. You can see the module leads coming off the module, going directly into the input of the battery. From the battery, the output goes directly into the inverter, and then the inverter goes output to a trunk cable that goes down to a junction box into the AC system. Some of the key specifications for the SolarLEAF, I want to point out here, up to 750 watt module sizes. Modules keep getting bigger and bigger and bigger as we go here. The nice thing about this is we have to say up to 750 watts because you're able to take that energy and push it into the battery. Nice thing about that is you're actually, any kind of issues with the larger modules, you're not going to have that any longer because now they're no longer able to clip. You're actually putting energy into the device. The device is then pushing out what the inverter can actually process. Module compatibility. This is a big one here. 1672 cell modules. And of course, that also includes the split cell modules for 120 and 144 cell modules as well. Big difference here, 60 volts and 12.5 volts amps input from those modules. Inverter compatibility, excuse me, is the Yotta DPI microinverter. Like I said, it's the dual power input inverter. The inverter is especially has special firmware in it to understand whether the power is coming from a module or from the battery. I mentioned the size. So 1 kilowatt hour battery today. And the chemistry is lithium iron phosphate, that was that LiFePO. Cycle life in commercial buildings, we're looking at 6,000 cycles, which is almost 18 years, used almost every single day. As I mentioned, weight-wise, 53 pounds here. Again, the same equivalent as 2 ballast blocks. Pressure on the roof, for any kind of loading calculations, we're saying 2.7 to 3, depending on the configuration. Mounting options. This is very, very good. It's like some demonstrations that we're showing here today are with panel cloth, but we have many installations with Solega, with Unirac, Iron Ridge, and even with Aero Compact. Operating temperatures here, all within the normal operating temperatures for inverters and for batteries, all living there on the roof. And size-wise, you can think of it as kind of a small suitcase. So it's a one-person lift. Very easy. This right here is just a plan set from Panel Cloth. This is the typical plan set that you would get when using their product. And what's nice about this is they give you the entire plan set, exactly where to put ballast blocks. And anywhere you see a 2 here, this is indicating the number of ballast blocks that are required for that location. Anywhere you see a 2 is a fantastic location for a SolarLEAF. Not to say you could put it in 1 as well, but it only requires 1 ballast block here. These right here, these 2 places are gold for the SolarLEAF. Nice thing about this is every single plan set that you get, well, from them will show you exactly where to put these ballast blocks. This right here is just an example of a system installed on a roof here in Austin, Texas. This just demonstrates the ease of installation, how it sets up, how that SolarLEAF is actually sitting there in that exact location where the ballast blocks sit. You can see here, this is not connected yet, but this right here is the input of the device. This right here is the output of the device. This piece you can just see here, we'll talk more about this later, is the communication port. This is where the wireless communication back to the online portal. So the big question is, why the SolarLEAF, right? This is really the key piece of this presentation. So we talked about this before, and just the cost, all the different hidden costs, and what we're really trying to do is simplify the installation and reduce costs for you, the installer, and for the homeowners. I'm sorry, the site owners. And as we know, with the traditional energy storage system, there's obviously the equipment cost. This is us. We both have this, both the Yotta systems and the traditional. To continue forward, we're looking at a lot of these things that are below the waterline. I think maintenance, engineering and design is a big one right here, because with the traditional systems, this is a AC coupled system. Where we're DC coupled, this is really simplified. It's just a plug and play on roof DC to DC system. With the larger systems, it does require fire suppression. You're looking at 100 kilowatt hour batteries, 250 kilowatt hour batteries, whatever they are, larger batteries. In the case of any kind of issue, they want to make sure there's fire suppression. Because it's on the AC side, there's independent metering going on. So it's constant there. If it's put outside, foundation or concrete pad, separate permitting is another thing right here. So these are all the costs that, like I said, we don't currently have with Yotta system because we don't require any of these things. Tailored installation, transformers, electrical disconnects, and of course, you're going to need some heavy lifting equipment to get these products, these batteries in those places. Where with the Yotta solution, the 53 pounds, it's literally one person can lift this to the roof, move it around very easily. So a lot of these hidden costs are disappear basically very, very quickly. This is just another way of looking at the data, kind of the same thing, looking at trenching, foundation, landscaping, all these different costs. So out of the box, just material costs, you kind of say, okay, we're about the same. But then you start adding on those hidden costs in there, it adds up real quick. So having the energy distributed throughout the roof, the batteries on the roof, and in a place where it's useful, you can actually store that power. All that weight on the roof right there is helping you with holding it down with this ballasting. And you avoid all of these extra costs, which are not costs that are associated with the Yotta SolarLEAF system. Also, with the batteries sitting on the roof, as we know, we have inverters on the roof that are capable of almost 450 watts AC out per channel, but we know solar panels are getting bigger and bigger every single year. So this is nice because with the SolarLEAF being able to handle up to 750 watt module, we're actually able to do that DC solar clipping recapture. Any kind of excess power that the inverter cannot process, the battery will absorb that, and the battery will then, SolarLEAF will then push that battery energy out to the inverter at the maximum amount that it can process and not allow any clipping. So we're actually able to store that energy and reuse that for future use, either that time of use, any kind of the demand charges, or energy arbitrage. And I think this chart right here just shows it very clearly, very easily. What do? This is it right here. Demand charge reduction. Again, using a system, using an acumen to be able to monitor the production, monitor the consumption of the building, and be able to react to any kind of spike in demand. That's gold right there. To be able to reduce those demand charges is really a huge cost savings to that site owner. Energy arbitrage, same here. If the utility says, hey, I need power and I need it now, how much power do you have and how much can you give me? This is where they'll be able to reach into your system and be able to discharge those batteries at their whim, but actually pay you for those power that you produced or have given to them. And of course, the time of use bill management right here. This right here, again, is those corner cases where customers are in jurisdictions where power doubles in price or whatever, but it just goes up to be able to utilize that power at a certain time and at a certain rate and frequency. So the big question is, how do we do it? One question we do get a lot: how do you take batteries and put them in such a harsh environment like a roof? Roofs are hot. especially summertime. We're seeing temperatures in Texas, in central Texas this week, almost 110 degrees Fahrenheit. It's been crazy. But the key piece for us, and some of our IP, we have 6 patents, all of which are in thermal management, none of which are in batteries. We're battery experts, but what we're trying to do is protect those batteries that live on the roof. You know, it's funny. I've been in the solar industry about 15 years now, and when we first started talking about microinverters and putting power electronics on a roof, it seemed almost laughable. We're just like, that seems kind of crazy. But we're 15 years in now, and microinverters have really shown that they can work in that environment. Designed properly, having that heat dissipation is a key piece. And at Yotta Energy, we basically have 3 ways to mitigate that heat. What we're basically doing is taking the battery cells that you see here and putting those battery cells in what I like to call, just for analogy, is a thermos. Think of it as a thermos that you'd fill up with coffee in the morning. You'd open the coffee up at 11 o'clock in the morning and it's still hot. What we do is we have a vacuum insulated board here, so basically ceramic board that surrounds the battery cells, all 6 sides. Those 6 sides right there will keep that in this kind of vacuum base. And vacuum is a very poor insulator of heat, so it won't allow heat to enter from external sources. We also have around the battery packs is a phase change material. This phase change material is basically a paraffin wax, and that wax, when heated to a certain temperature, will then go from a solid to a liquid, dragging or pulling the heat that is generated from within the device out of the device. And underneath all of this, there's 3 heat pipes that are pulling the heat out to these fins on the outside of the device, again, to cool the battery, to cool that inside of that device, to make sure. What we wanted to say is, like we say here, the Yotta temperature range. This is the sweet spot for the battery. Any of this particular technology, this chemistry, wants to live and work in an environment from like 100 degrees F to 70 degrees F. So what we're trying to do is maintain that temperature within that range for the highest performance of the battery and have the longest life of this particular battery. So no moving parts. So again, no maintenance for this for the life of the product. There's no fans in here. It's all very passive. All happens by itself. So this is how we mitigate the heat going into the device and getting the heat out of the device. So you may ask yourself, hey, I live up in the northern climate. It gets cold up here. We don't have to deal with the other side of the heat problem, cold. We also have internal heaters inside the device here, which will come on. And either the solar panel will generate enough power to run the heater to warm up the batteries to keep that temperature within that Yotta temperature range, 70 to 100 degrees F, throughout those cold spells as well. So we think about it from both sides. We want to mitigate. What the biggest problem is getting the heat away, but the smaller problem is adding heat, and that's actually done by these thin film heaters. Safety is a big one, right? And we want to make sure that we have a safe design. And I think the key piece right here is low voltage DC system. Everything on this roof, everything inside this battery, all of which is under the 80 volts DC touch safe for NEC. Number 2, LFP chemistry. It's the safest in the industry today. It's been proven that it's been clean. It's very useful and it has a very difficult time and kind of propagating any kind of issues and thermal runaway. Yotta has gone through the UL 9540A testing, actually done it twice, interestingly enough, with no external flaming. There has been nothing, not even a puff of smoke has come out of the device itself as we were doing it. As I mentioned, the battery itself has a layer of the thermal ceramic insulation. So that's that vacuum board that I was mentioning, that thermos, if you will, which acts as a fire blanket. So it's fire protection. If there's any kind of issue, you have a vacuum and a fire blanket are wrapped around all of the batteries on this particular roof. Now, the key piece is distributed by design. These modules are scrubbed throughout the array. The SolarLEAFs are under the modules, which means that each battery is further than 3 feet apart from each other. So if there was any kind of issue, which we have not been able to produce through the UL 9540A testing, the batteries themselves are 3 feet apart from each other. So if there was a thermal runaway on one device, it wouldn't crawl across the roof and head to the other device. Again, making it very, very safe. In conjunction with the modules and the batteries, the microinverters themselves meet the NEC 2023 rapid shutdown requirements. What's interesting enough, it actually will shut down within 1/10 of a second. Current code for 2023 says it has to be touch safe within 30 seconds. We do it within 1/10 of a second. As soon as AC is taken away from the device, the only conductors on the roof that are energized are obviously the ones coming from the solar panel to the battery, which are absolutely under 80 volts, and anything coming out of the battery is under 80 volts as well. Again, making it touch safe according to NEC. We have a case study here. I like to bring this one up. This is actually kind of nice. This is a case study that's actually out of California. This we have a test site that's been out there probably all of 5 years or so now. At CSUDH. This is Dominion Hills, just outside of Los Angeles. And there was some time when the temperatures in Los Angeles would hit almost up somewhere in the ambient temperature range of 120 degrees in the outside areas. What we're demonstrating here is the temperature that the ambient temperature was underneath of that module, but the green line is actually demonstrating that we're staying within that Yotta temperature range. We're making sure that everything inside that device, where actually all the action is happening, is in that happy place. So we're seeing we're well under, even though the temperature rose, and you can see the temperature rising during the day, but we still maintained a temperature between 100 degrees F and 70 degrees F during that event, even when the external temperatures were sitting in 140 degrees underneath that module. I want to pause here for a second. You guys, if you want your phones, you can take a look at that QR code as well. You can download the entire case study from our website. But what's nice about this is you can have a lot more data, but this just gives you an idea. It's 2 different days. SolarLEAF performance on June 10th, and you can see the sun coming up in the morning. You can see the solar charging throughout the day. This is your typical bell curve right here. You can see this is the charge. In the morning time, we're charging the battery. And then when the battery is fully charged, it stops, right? So then we have this period of time, we wait, and this is where we're doing the discharge during the day. This is the time of use. So they wanted the battery to come on, so we turn the battery on at 4 p.m. and let it run until 7 p.m. and then it shuts off. Same thing here. SolarLEAF performance in September. You can see that the day is changed a little bit. So from July, or this is June, from June to September, the bell curve has changed shape just slightly, but we're still discharging at 4 and shutting off at 7. The nice thing about the discharge in this time of use, you can actually tell it exactly what time to discharge. You can tell it how much to discharge and for how long. Those are the kind of 3 settings that you, the user, can set for your customers, if this is the method in which you choose to use the battery. This is a value comparison of a traditional system as opposed to the Yotta energy system. We have lots of data on this, and let's definitely reach out to Ryan, reach out to any of your regional sales managers. They can actually help you with this particular project for your projects. But this just gives you an idea of a system that we did for a California winery. And looking at the Yotta energy side, 2.1 years for payback, as opposed to a 5.8 year payback for the payback period. The internal rate of return, 30.6, definitely a lot higher than the 21.4. And of course, big one right here that's really obvious one is electric bill savings, $2.9 million as opposed to the 1.3 from a traditional ESS system.
Chris, I'd like to point into that's a fairly conservative modeling too. We like to make sure that we're giving you a very realistic interpretation of what we think. And so our salesperson, specifically on the West Coast, is very conservative in his modeling. So this is kind of the low end of what you can anticipate.
Fantastic. This is just a couple of pictures of some of the installations that we've done just recently. This is Polaris Industries. This is the UTV or ATV company. They're actually going solar on all their buildings, and we actually provide the solar and storage for them. Texas Department of Retirement here on the upper right. Again, Polaris down below, and then Victory Church here in town that has just actually adopted solar and storage for their needs as well. Let's talk a little bit about system configuration and what that actually means. As I mentioned before, you can actually hook up the systems with solar modules, down to solar modules here, down to inverters, and then out to the AC. This particular case right here, we're actually demonstrating the 208 volt 3-phase DPI 208. Nice thing about this particular product, it is a 3-phase, phase monitored, phase balanced inverter. There's no more balancing that you need to do. It's all done inside of the device itself. With the 208 system, we can use up to 5 units, 5 inverters on a 10 gauge trunk cable to a total of 20 modules. You can do smaller if you want, but the maximum you can do for a 208 system with that current is 20 modules or 5 of the inverters. If we fast forward over to the next system, it's 480 volt, and this is really nice for the commercial environments as well. Again, phase monitored, phase balanced, 1800 watts AC, which equals 450 watts per module. That's AC output for a total of 1800 watts. Again, the nice thing about this with 480 volts, as we know, voltage goes up, current goes down. I'm actually able to put up to 11 units on a 10 gauge trunk line. So a total of 44 modules going down to a single 30 amp 3-pole single throw breaker in your AC sub panel. Talk about simple installation. Very, very simple, very easy to install. So of course, now, you know, this is your solar configuration. Let's say you want to add storage. Boom, same thing. You can actually put in here, here's your modules going into your SolarLEAFs, demonstrating this is a 4-module set, 4 SolarLEAFs going into a 4-port microinverter. Well, over here, we're also demonstrating as well the DPI. We're saying, okay, maybe you don't need a full complement of storage. Maybe you only need, 25% or 30% or whatever you need of your system. I can put a module, I can put a battery into this DPI, and over here is just module directly into the DPI or that dual power inverter. All of which goes down the trunk line, again, back to that sub panel, 30 amp, 3-pole, single throw breaker. Phase monitored, phase balanced. Let's talk quickly about the DPI itself, just so it's all clear what this actually does. Like I mentioned before, it supports 4 high capacity modules, gives you the flexibility for the 208 volt or 480 volt systems. And I think the most important part for me, 3-phase, 4-channel, and advanced monitoring, Zigbee mesh network, and easy installation. So as far as this is concerned, you couldn't be easier. You're putting your modules directly into the ports down here. The Zigbee antenna is now your communication. It's a wireless communication. The AC is, again, phase monitored, phase balanced right out of the inverter itself. In review, 208 gets you to 432 AC watts per channel output. The 480 gives you 450 watts. Native 3-phase, line 1, line 2, and line 3, phase monitored, phase balanced. UL 1741 SA California Rule 21 compliant, and also rapid shutdown compliant. That's 690.12 for 2023. For those of you not familiar with microinverters or AC trunking, I'm just going to give you an idea. This just gives you an idea of how a system, whether using a 208 system, how this would actually work. Each of the devices is capable of 4.8 amps. So every time we're going to add one, we're going to add 4.8 amps to 9.6, 14.4, 19.2, all the way up to 24. If we're adding the 5th unit, so 5 times 4.8 is going to give us the 24 amps, which is the maximum we can put on a 30 amp breaker. So this is a single string. So now you've got 5 inverters, 20 modules, all of which is producing a maximum of 24 amps sitting on that 30 amp 3-pole single throw breaker. So the microinverter solution, like we talked about, is more of a review, rapid shutdown compliant. I think a lower cost of over the lifetime system because you're actually producing more power. I think we have reliability with a 25-year warranty. And of course, safety is a big one. Accommodates the 60 and 72 cell modules, of course, with the split cells as well. The integrated Zigbee Wishmire network, this right here is for communication purposes. This, instead of going over a power line communication like many microinverter companies do, this is actually wireless, so it gives you a lot more flexibility, especially in a commercial environment where you're gonna have lots of noise in the lines. Going over the air, a lot more reliable communication and faster as well. If there's any kind of need in the future, we also do sell a different product called the ECUC or a gateway, which has CTs available for monitoring consumption, both production and consumption. More of a review here again, but rapid shutdown, more generation, 25-year warranty, panel level monitoring, and expansion with ease. I won't spend too much time on these, but there are accessories that come with these with the microinverters themselves. The trunk cabling itself is a 3-conductor cable, 4 meters between drives. They land on a 30 amp breaker, and in review, 5 units for 208, 11 units for 480. These are some of the end caps. These are the if you miss a drop cap. People always ask, let's say you have an odd number of modules. You have a 4-port inverter and I only need to use 3 of those ports. We recommend you just use a DC cap. This is actually made by MC4. It fits right in. It seals that cap watertight and dust tight. So here's some of the specification sheets right here. I'm going to pause here for about a minute on each one. This talks about the specifications for the SolarLEAF itself. We talked a little bit about this earlier, but take a second, scan that if you'd like. If you don't, or we can get you a copy, reach out to your RSM or come to our website and download these as well. Okay, I'm gonna move on. This right here is the QR code for the DPI 208 and 480 volt inverter. All right. Let's talk about the online monitoring. As Ryan alluded to in the beginning, I think this is actually kind of a nice piece to be able to monitor systems remotely, to be able to see what's going on at any given time, pretty much from anywhere in the world, to be able to see. The nice thing is you can monitor and analyze every single microinverter and every single battery that's on that roof. We're going to be pushing information, taking information from the site every single 5 minutes, and every 15 minutes push it to the cloud. And then publish that. You'll be able to see that from a mobile phone application, also from your desktop computer. The remote access is critical for today's systems, to being able to monitor and troubleshoot. If there's any kind of issue on the roof, the nice thing about a microinverter system is you're going to be able to locate exactly where that microinverter is and exactly what channel is an issue. If it's a problem with the inverter, or if it's a problem with the module or the battery. Communication in real time, as I mentioned. This is every 15 minutes from the site. If you're on site, it's every 5 minutes. And the graphs to be able to do troubleshooting is key for any kind of future O&M for a commercial system, especially larger systems. Being able to have a system, being able to get notified of an issue, number one, and being able to diagnose that issue very quickly. For example, we had a customer recently call up and said, "Hey, we're a new customer. We've just had our first failure. We'd like to see if we can get a new inverter." And we logged into the system. We were able to see the system. We were actually able to diagnose all the way down to the module level. This one module was not performing as well as the adjacent module. What we found was one of the diodes had been tripped on the module itself. So the inverter was actually fine, but the inverter was telling us that the module was bad. We were seeing that the other module adjacent to it had 36 volts input into the inverter, and the module that was the problem was 24 volts. So you can see it's 1/3 of the total voltage coming out of that module. Customer was able to, bring the right product to the roof for troubleshooting, for repair. So it saved him time because he knew exactly where the inverter was, he knew exactly which channel to replace, and he also did bring the right product. So time on the roof was minimized. He had to still roll a truck, but the nice thing about it is the inverter itself alerted him to the issue, told him exactly what the problem was, and he went to site with the right amount of equipment. So really quick on site to fix the problem. With the online monitoring, you're also able to see, your daily performance. You can go back in time. You can pick different dates here and go back and see what's happening. You can also look at different module by modules. This right here is a good example of, I'm looking at the channel 1 and channel 4 on the same exact module here. I can graph them together and see their tracking, see their performance. If there is any kind of issue, they would actually jump out very quickly here. Down here, we're actually able to turn on and turn off certain pieces. Let's say I didn't care about the module power. For these two, I could turn these off. This graph would actually shrink, but actually able to see the voltage and temperature a lot easier. Other nice thing about the system, the online system, you can actually download any kind of report that you want. You can come up here and pick the type of report you want, select the date, hit the query button, and then all the information will populate here. Then you just go to this button here. You can export this information out into Excel, CSV files, PNG files, whatever you want, many different output methods. We also have right here is basically Yotta Vision. This is the next generation of the online portal. Not currently available, but will be soon. I imagine there's probably going to be some kind of a big show in September or so. We might want to talk about it at that show. But this is where we're going to pull all the information from the inverters, from the batteries, from the modules, all into one location. So have a single source for all of your monitoring for your system. And like I said, this is actually coming soon, and looking forward to having this out really quickly. How do we make it happen, right? And I guess really the key piece is this is really the brains of the operation. The inverters themselves, once they see power and proper voltage, proper frequency, they'll come on and produce power. The manager or the monitoring system right here is the piece. This right here is the wireless communication or Zigbee communication. This is sitting on site, connected to the internet, being able to take that information from the site and push it directly to the cloud. It can be connected to this internet via the Wi-Fi, Ethernet, or cellular dongle plugged inside via a USB port. The configuration is pretty simple. You can see here the antenna for Zigbee, the antenna for Wi-Fi, obviously a power protection port right here. This gives you the port. The power LED tells you that the system is up and running and producing power. The COM light tells you that you have internet connectivity and communication to our servers to be able to see this information remotely. As I mentioned earlier, we talked about different kind of communication methods, and the industry itself has seen a lot of changes. In the beginning, many customers, including ourselves, used power line communication or PLC. This is communication of the devices to the inverters back to the gateway over the power lines. That's all well and good, and it's actually great technology and actually pretty fantastic. It actually travels quite far, but some of the limitations are, I'd say, crosstalk or any kind of interference on the lines, especially in commercial C&I buildings. If there's any kind of commercial environment, motors running, you get a lot of noise on the lines, and you may not be able to reliably communicate to those inverters or batteries. What we've done is I changed over to Zigbee communication. And Zigbee communication, I put a Wi-Fi here just as an example. Zigbee communication is very, very similar to Wi-Fi in the sense that it communicates wirelessly. Wi-Fi that we use in our businesses and homes is what they call a point-to-peer network. The point being the router, the Wi-Fi router, the peer being the device. Here you can see, I'm just make an example, you can connect the Wi-Fi to your computer, Wi-Fi to your tablet, Wi-Fi to your phone. It's a point-to-peer, it talks back and forth. Zigbee is very similar in the sense that it wants to be a point-to-peer. It wants to talk to each inverter individually. So I don't want to talk to you, I want to talk to you, I want to talk to you. But for example, Ryan is on this call right now, and I'm trying to talk to Ryan. He's on the call, I can see him here, but he can't answer me for whatever reason. I'll ask his neighbor and I'll say, hey, Steve, can you talk to Ryan and ask him this question? This is where you get to what's called the peer-to-peer network. So the gateway wants to talk directly, but if it can't, for whatever reason, there's an interference too far, whatever the problem is, it can ask the neighbor, say, hey, can anyone else out there talk to Ryan? And this inverter says, yeah, I can talk to Ryan. So they establish this Zigbee communication line back and forth. So when the questions are asked, this Zigbee router will ask and say, hey, Steve, talk to Ryan, ask Ryan this question and get the information back to me. Self-healing mesh network. This one change that we made has literally reduced our phone calls by 50% for the configuration and setup of the system. Gold, absolute gold. This right here is just an overview of the system we just talked about. 4 modules going into 4 SolarLEAFs, going into a 4-port inverter, going directly out to the AC combiners, out to the main service panel. Installation, again, couldn't be easier. This right here is, again, an example of a panel cloth. But again, I'd like to recommend, we do work with Solega, Unirac, Iron Ridge, AeroCompact. But as you can see here, we've got a system sitting here on the floor in our laboratory. We're actually going to install a mounting plate for the inverter. The inverter then will mount to the PEM nuts that you see here. So this is for proper grounding to the racking. From there, the inverter is installed. The battery of the SolarLEAF will actually get installed right into the racking. A ballast block if necessary. These connections, the input from the solar module here, and then the output to the inverter. And you can see here, this is the system all connected together. The module coming down into this side here, into the battery then output to the inverter, inverter output to the AC trunk line. So in review, energy storage solution for the SolarLEAF is simple. We're looking at a solar module that's sitting on the roof. That module is then connected to the input of the SolarLEAF, goes through the SolarLEAF, through the battery management system to the output. The output then goes into a single port on the DPI 208 or 480 native, then out with the AC out to the building. So some of the advantages, the lowest cost of installation. We really do believe that having these systems manageable by one person, easily carryable, plug and play, DC to DC on the roof, is really the coolest way to go. Installed with the PV solar. So development, easy implementation, done. Accommodate future load demands. Like I said before, we can have a system today that is solar ready. We can have a system today that has some SolarLEAFs or a full complement of SolarLEAFs. And safe. So the chemistry itself is very safe. It has passed the UL 9540A and 9540 testing. And everything you're seeing here is low voltage with remote monitoring. Right?
Thank you, Chris. I'll give you a second to kind of catch your breath and get a drink of water, and then I'll hit you with a couple questions. We're running close up against time. You can see we have a number of partners. You could find us at your Green Tech branches nationwide, as well as Kranick distributors. And we have relationships with Power Store and other fine distribution outlets. If you would like our product to be carried at your distributor, please let them know and get in contact with us, and we will work our best efforts to get in stock with them. We offer a number of different partnership services. We're not just a manufacturer. We do a lot in the background here. Some would say too much, but we got a great team, and everybody gets involved and throws their hand in to help. We do proposal generation. We will do the engineering and plan sets. We will do equipment procurement. We will do installation and construction support. In fact, that's most likely where you'll meet Chris. He is more often than not on the roof and helping on new installs. So we're happy to participate there. We also offer support on project finance. We're going to be doing a webinar, I believe it's next week, with one of our financial partners called Sunstone. We've got a lot. This used to be a real problem for people, is finding project finance. We've got an embarrassment of riches as far as project finance goes. So if you have any questions about that, we've got a lot of companies that we could put you in touch with, as well as ongoing maintenance. So there are a lot of different things we do besides just manufacturing and selling the product. Our Yotta swag giveaway winner, as selected by our marketing team, is Rick. Rick, congratulations. Somebody from marketing will be reaching out to get your contact information to send you the Yotta swag giveaway. Thank you very much to everyone who attended today. We'll move on to Q&A here very shortly. Chris, you ready?
I am ready.
All right. All right. Do you see any major issues with different types of commercial rooftops with installation? Are these 100% non-penetrating?
Great question. Great question. So it really depends on the racking manufacturer and their particular requirements. I would say that at this point, strong 90% of all the commercial installations that we have done have been zero penetration. All the ballast blocks will help you hold it down. Wind loading, it really depends on the design of the building itself, because if you have large parapet walls, you have less lift, less chance of lift. But like I said, there's been some buildings that we have had that have had minimal mechanical attachments. And I'd say that's probably 10%, probably even less than that, but 10% is a good conservative number. But that, refer to your racking manufacturer for that.
Someone may have caught us on an error on one of our slides, Chris. Let's see. Matt says he thinks he saw a few different module ratings on different slides. On the configuration slide, it showed a wattage range of 250 to 440, whereas on others, I think I saw higher ratings. Does the max DC input ratings vary depending on whether the leaf is used?
And actually, that's funny you point that up, Matt. So I appreciate that. I did see it myself and said, "Uh-oh, I did a bad job editing." So yeah, that is actually an error that we will fix. That it's a typo. Speaking of that, so the module ranges, we're looking at modules in the 550, 600 range. Will work nicely, nice complement for both the inverter and for the battery. The battery can take up to 750. So if you have a 750 watt module going directly into the battery, boom, that's going to be fantastic, and like no clipping. The inverter itself, I would say 600 is probably the best case scenario. Would be you had minimal clipping if it's going directly from the module to the inverter. But one thing we do need to look at is the STC versus PTC of that module. We always talk about modules in their STC size, but we all know that most modules will never ever get there. Interestingly enough, the state of California is all their designs and all their calculations based on the PTC or NOMT of the modules themselves. So if you have anything special, any particular modules you're talking about, please send them on to us, the tech support team, or any of your regional salespeople. We'll take a look at it. But the most important thing for me for the modules is the output voltage and output current. Those are the key pieces that we really care about. As long as it's within our normal operating range, under 60 volts coming in and under 20 volts, so about 20 amps, sorry, the module will work just fine with both our products, both the inverters and the SolarLEAF.
I feel like we could do a webinar just on STC versus PTC, Chris. It's amazing how many people kind of overlook that. I mean, I've been in the industry for a good long time, and it's only something I realized, in the last 4 or 5 years when you drew my attention to it. And it really changes the way that you look at things. Yeah,
absolutely. And I probably should actually put that together. I think it's a great idea. And it's an industry thing that just we always talk about, how big of a system do I have? Well, I got a 10 kilowatt system, but then you really look at the PTC, the actual practical side of what the modules are going to produce, and you're really got a 7.6 kilowatt system. That's the AC side. What can you realistically pull out of a module? So yeah, let's make that happen. I love it.
Chris, can we program the SolarLEAF battery to run at lower peak power for a longer duration? Example, if I have 400 SolarLEAFs, but programmed to run for 100 kW for 4 hours.
Absolutely. So I wasn't clear about that. Sorry. So yeah, so if you're using time of use, you can actually pick the time at which you discharge. You can pick the rate at which you discharge, and then the number, the length of time that you discharge. So yeah, so looking about it from a 1 kilowatt hour battery perspective, let's say you wanted to run it for 100 watts for 10 hours, sure. You could definitely do that starting at 4 p.m. So those are the three variables. Boom. Time of discharge, the rate of discharge, and the length of discharge. All programmable.
We have a number of other questions, but like I said, we're up against time. We'll make sure that we follow up within the next day or two. Someone from the sales team or Chris himself will follow up on these remaining questions. We've got a decent amount of them. Sorry, we went a little long. Chris, you were extra verbose today, which made a good webinar. But we'll get to you, I assure you. Yeah, so this is a big one, right? It's the one we all wait for every year. Come on over and meet us. Chris and I will be there. The entire sales team will be there. Executive team will be there. We're going to be in Vegas. Come on by. It's a great place to attempt to do some work, I guess, in Las Vegas. But yeah, we're excited to be there. It's always a great show to touch base with everybody and see our customers. But if you're interested in getting a formal meeting with us, reach out to any of us at sales@yottaenergy.com. We'll be happy to get you a meeting with the appropriate parties. The next webinar is the commercial frontier, empowering businesses to go solar. You can reach us on our social media platforms. LinkedIn, Twitter, and Instagram are @YottaEnergy. And I guess we couldn't get that one for Facebook because there we're @YottaEnergy ATX. Of course, our website is yottaenergy.com. General support line is support@yottaenergy.com. For sales-related questions, you can get us at sales@yottaenergy.com. Our direct line is 833-MY-YOTTA. You can get Chris or I directly at ryan@yottaenergy.com, or you guessed it, chris@yottaenergy.com. But thank you very much for joining. We're always happy to see you. We hope we see you on the next one. If you have any suggestions for topics you'd like to see on one of these webinars, or something that we haven't covered, or something you'd like to see us dive into, please let us know. We're looking for ideas for new content so we don't keep talking about the same stuff over and over again. And for those of you who join us every month, thank you very much. We do notice you and we appreciate the support. Everybody have a great rest of the day, and we hope to see you in Las Vegas.